So ionic and covalent bonds. How are two atoms held together in a covalent bond? There's one word I'm looking for that's a key word. Begins with the letter S. Yeah. Shared. Shared electrons. Then number 3 is a bit more obscure. It says, what causes ions to come together? Now, we haven't done our electricity unit yet, but in our electricity unit, you're going to learn the following. Opposite charges attract each other. And so a metal ion is a positively charged, a nonmetal ion is a negatively charged, and just like on a dry day, you may notice your clothing when you pull it out of the laundry wants to stick to each other with static cling. Believe it or not, that's also what's going on in ionic bonds. Positives and negatives attract each other. It says, explain why the ions of sodium and chlorine will arrange themselves in an alternating fashion inside a crystal lattice. Well, each positive ion, which is a metal, wants to be surrounded by negative ions, nonmetals. Oh, and the reverse is true as well, Lena. Each non-metal negative ion wants to be surrounded by positives. Well, the only way you can do that, if you think about it, is to have this alternating pattern. We call it a crystal lattice because depending on how many of each, you get different shapes, but I showed you a couple of pictures. In fact, we saw a little video of sodium chloride. I'm not that fussy about number 4. Number 2 and number 3, you absolutely need to know. When lithium reacts with fluorine, fluorine takes an electron from lithium, forming 2 ions. The positive ion is, okay, which one loses an electron, lithium or fluorine? This you need to know. Lithium. Lithium. Lithium? Lithium. Oh, and then by, I guess, process of elimination, the negative ion is. And if we were combining together, we'd bring the Ide rule in. Says draw the Bohr diagram for each ion and remember the charge. Okay. So I'll do lithium in red. It has 2 electrons. Now normally, don't write this down, this is wrong. Normally lithium has 1 electron, but I'm going to erase that. It wants to get rid of that electron. It's an ion with a charge of +1. What about fluorine? Well, fluorine has 2 inner electrons, and then I go down a row. It's in row 2, so the next shell is going to be full of 1, 2, 3, 4, pair, pair, pair. Now that's a fluorine atom, but it's picked up the extra electron from lithium. I'll do it in red, Nathan, so you can kind of see what's going on. And that means because it has an extra electron, it's got a charge of -1. That's probably on your test. I'm going to ask you to draw some kind of a Bohr model of a compound. It'll look something like this. To show their ions, Kyle, we go square brackets, we put the ion charge, and then think very carefully when you're drawing the electrons, and you can get those from the shells. Number 6, I'm probably not going to ask you on the test. This was just for nerd trivia, and it said, look at page 80 for help. The polyatomic ion that's in eggshells as well as in teeth, that's, I believe, CO3 with a charge of 2 negative, if I recall. Carbonate. It's in your enamel, it's in your eggshells, it's in limestone. You know, if you wrote CO3, that's shorter, but I'll put both so that you know. A polyatomic that's sorry, let's try that again. Polyatomic ion that's present in your bones is phosphate. Now that's the name. What's its formula? Hey, I have my handy dandy periodic table, flip it over. Phosphate is PO4. Has a charge of 3 negative. I'm not going to write the charge unless I'm crisscrossing. Two polyatomic ions that contain the element nitrogen. One positive, well, NH4, which is ammonium. And then there's several that are negative. There's nitrate, there's nitrite, so you can have NO3, NO2. There's probably more, but those are the ones that are on your formula sheet. Says, use the diagram of the phosphate ion shown to answer the following questions. What kind of chemical bond holds each oxygen atom to each phosphorus atom? You can figure it out. Oxygen, metal or non-metal? Phosphorus, metal or non-metal? This is two negatives bonding, two non-metals. That's always going to be covalent. How many atoms? So if you look at the picture, the orange one, your guys' is black and white, I realize, but I think the orange one is supposed to be phosphorus. How many oxygen atoms does it connect to? 4. I'll put oxygens, although I just asked how many. If you said 4, that's fine. And then this is going to be important, certainly for part C. What's the general term for an ion, such as phosphate, which is a molecule that has an overall electric charge? It's on the back of your sheet. It's what we call these things. You need to know this word. What does it say in the heading, Lena? Polyatomic ions. They're ions, they have a charge. Poly means many atoms. They're charged groups of atoms instead of just single atoms. Polyatomic ions. Again, ions means you have a charge. The number of protons and electrons isn't balanced. Polyatomic means many atoms. The crossword, I'm going to assume that you can kind of figure out on your own. There's the clues. So hopefully that gives you, some of you were asking about that. I'll throw the answer key for this online later on tonight. But for now, having talked about that, what I really want to do is, if you can go back to section 3.2 notes, this handout here, we had reached all the way to nearly the last page. Lena, you were away last day. Farine, you were away last day. Omid, you were away last day. So look at a neighbor to see how far we got. Looking at my PowerPoint, I have pause here. So we got to sodium permanganate, which for you guys is question number what? Question 10? Yeah. Yeah? Okay. We had gotten to number 10, which was right about here, and apparently we did the first three. We'd stopped on sodium permanganate, right? So on your test, in fact, on your take-home quiz today, I'm either going to give you a formula and say, tell me the name, or I'm going to give you the name and say, tell me the formula. Then on Thursday, I'm going to give you another take-home quiz. I'm either going to give you the formula and say, tell me the name, or I'm going to give you the name and say, tell me the formula. Then on Friday, I'm going to give you another big Uber take-home quiz, and on there's going to be lots of names and formulas, but also a bit more, because we've got one more lesson, one more topic to cover. Okay? So I'm going to go back to my handy-dandy-schmandy PowerPoint, right? Oh, wrong one. This one here. It says pause. We will continue on Tuesday. Today is Tuesday. So how would I write the formula for sodium permanganate? Sodium, I know what that is. Permanganate, is that an element on the periodic table, or is that a polyatomic ion? Okay, so if I'm going to get the formula, I'm going to use the crisscross rule. First thing I do, off in the margin, how about right here, I write sodium and its charge. Is sodium multivalent? Please tell me no. Okay, What's its charge? Plus. Permanganate. That I have to find on the back of my periodic table. Psst. You know where we are? Got the notes? Ready to go? Got to find it. Okay, can you find them, please, kiddo? If you can't, I'll get you an extra copy, but you need to find it. Permanganate. What's that? Go ahead, read it to me. M, little n, O. That's the ion, and since I want the formula, I'll put the ion charge. What did you say it was? 4 minus. So, if I'm trying to get the formula, it's going to be, how many sodiums? 4. How many permanganate ions? 1. Am I going to put a 1? Nope. And again, if you want to, you can put it in brackets, but technically that's bad chemistry manners, so you don't need to. Was that a phone I just heard? I heard a phone from the corner there. Rihanna's looking very, very sheepish right now. Is it her phone? She's going to bring us Timbits on Thursday? Oh, that's so nice of you. Make sure we're all nice to Rihanna. Ammonium nitrate. Ammonium. Is that on the periodic table? Okay, that's a polyatomic ion. Ammonium. Damon, you got your periodic table out? Or Hudson, do you have your periodic? You got one there? You want it in front of you, probably, or handy. Ammonium, Damien, what's that one? Can you find it on the polyatomic ion? I think it's on the left column, yes? What is it? NH4 charge? Plus. And nitrate. Did they say nitride? So this is not nitrogen. This is nitrate, which is also on the back of the pink sheet. Damien, what's nitrate? Yeah. Not ite, not I. And I know the naming is stupid, Mitra. You got to pay attention. I can't change that. Nitrate is what? NO3. Charge? NO3 what? Negative? Oh! So this is a nice crisscross. 1 and 1, right? It's going to be 1 ammonium ion, polyatomic ion, and 1 nitrate ion. Yep. That's NH. You got your pink sheet? It is. Ammonium is NH4, is it not? I think so. That would be ammonium nitrate, and the crisscross rule is 1 and 1. By the way, who remembers, because you were away, how could we tell from the formula that it was a polyatomic ion? More than 2 capital letters. That tells you that there's 3 elements, Kiana, or more than 3. Magnesium hydroxide. Magnesium hydroxide. Well, magnesium, is that on my periodic table, Dan?
Yes.
Element or polyatomic? On the front page? Okay. Mg, what's its charge? 2 plus? Hydroxide is OH. What's its charge? Negative. Now I crisscross. The formula is going to be how many magnesiums? 1 or 2? 1. How many hydroxide ions? 2. Why is this wrong? Because this is wrong, the way I've written it. No? No? Right now, that 2 is only on the hydrogen. It's not on the OH. I need to show that there's 2 OHs. How can I do that? There's a word that begins with letter B. 1 magnesium, 2 OHs. By the way, how many atoms are there grand total in this molecule? Let's see. How many oxygens right here? 1. How many hydrogens? 1. So in the brackets, how many atoms are there? 2 times 2 makes 4, and 1 magnesium makes, this molecule has 5 atoms. 1 magnesium, and then a pair of oxygens and a pair of hydrogens. Let's skip sodium dichromate. It's cool, but let's do lithium phosphite, the last one. Lithium, I know, is Li. Has a charge of plus. And phosphite, I always got to be careful. Did it say phosphide? Is it IDE? So if it was IDE, I would just use the phosphorus from the front because it'd be the IDE rule. It's an ITE, and Pierce, you got to spot that. I hate the names, but I can't change that. Aiden, what's phosphite? PO what? 3 with a 2 negative charge. So when I crisscross to make this work, for this to be a stable compound, for this to be balanced, it's going to be how many lithiums? 2. How many phosphite ions? Oh, it's 3 negative. Were you reading phosphate? And again, it's easy to have your, by the way, I'm glad you did that. It's easy to have your eyes move to the wrong column. Just be really paranoid on the test, right? It's 3 negative? Yeah. So when I crisscross, it's going to be 3 lithiums. And how many phosphites? Just 1? Turn the page. If your teacher was mean, is that a question, Jordan, or a stretch? Oh, there's not a 3. Sorry, why did I put a 3 where? Because you got your pink sheet? Look at phosphite. Okay, if you don't have your pink sheet, I can't help you. Look at, not phosphorus, turn it over. Look at the back. Find phosphite. What's its formula on its own? PO3. That's why I got to write a PO3. How many PO3s are there? 1. Okay? So, by the way, if you don't have your pink sheet out, you're selling yourself short on this stuff. I'm telling you, what I really did was this. Okay? It's phosphite, Jordan, and phosphite as a formula is PO3. That's where that 3 there comes from, the fact that phosphite, the polyatomic ion, is a PO3. Then when I crisscross, I see how many of them do I need. Yeah? They do. What do you mean? Can you find? Oh, okay. And you weren't here for this. It's a good question, but they should. You scared me for a second. So, Jordan, I'm going to get rid of the brackets if that's okay, but here's what we're saying. 1 PO3 ion, which is a polyatomic ion, and 3 lithiums. Is that okay? Turn the page. If I was mean, I'd give you multivalent. So you ready? Copper, multivalent. What charge am I going to use? How do I know they want me to use a copper charge of 1? Because it's the Roman numeral. So I'm going to write Cu. Copper? I don't know. Look at it on the periodic table and tell me. And it's a metal. Oh, you guys have, positive ion, negative, you have more columns. Copper is the, you know what? You can write the rough work then in where it says positive ion. You can put a little Cu plus, Cu1 plus. The negative ion is the hydroxide. That's right, I gave you room to work, but I couldn't fit it on my PowerPoint to make it big enough to read. Hydroxide is OH, right? OH what? Oh, this is a nice crisscross. So put the OH negative in the negative ion column. Crisscross. What do you get? CuOH. Cuo. Copper 1 hydroxide. What if they had said, don't write this down, what if they had given me, what's another charge that copper can be? 2? What if they had said copper, well, don't write this down, I'll just erase it. What if they had done that? Well, then I'd have a charge of 2 here. I'd have 2 there. Oh, you have the next one is copper 2 hydroxide? Doesn't appear on mine for some reason. Okay. Dueck, you didn't carefully make sure that you have all of their examples. So copper 2 hydroxide, what would that do then? Put a 2 there, right? Crisscross, and you would end up with this. So I'm going to change it on mine. I'm going to put a copper 2 like that, and that would give you what? How many coppers? 1. How many hydroxides? Put it in brackets and a 2 outside to say you need 2 of those. Your next one is lead 4 dichromate, is that right? Okay, so let's do that one next. What's the positive ion? Lead. What's the charge on lead? Multivalent. Oh, no. Which charge do they want me to use? Lead 4. So over here in the margin, for me, you guys have a little spot to put it on your chart. I'm going to put lead with a charge of 4 plus. What the heck is dichromate? Oh, that's a polyatomic one. I think that one is Cr2O7, is that right? With a charge of 2 minus. You can put that in the negative ion column. Did you find your notes okay? No? We're on the last page. Yeah, last page? Yeah. Yump. How many leads? And I'm going to give you a hint. Don't say 2. Ready? If I crisscross, Dan, if I put a 2 there and then I put a 4 there, why is it wrong to have a 2 and a 4 there? Lowest terms. Right? So it's going to be how many leads actually? 1. And then how many Cr2O7s am I going to need? Not 4, but 2 of them. That's lead 4 dichromate. So there is kind of a systematic way to, get through this. It's ugly, but doable. Is your next one iron 2 acetate? So I'm going to move up one on my chart, but you guys are moving down one. Iron, multivalent, which charge do they want me to use? So iron is Fe, and they want me to use 2 plus. Acetate, that's Chku, CH3COO. CH3COO and a negative. Okay. Crisscross. Let's try that again. Final formula. Fe's, irons, how many? Sorry? Oh, just 1? Am I going to write the 1? No. Again, you can. I'm not going to because I'm lazy. And then how many acetates? How many CH3COOs? In brackets, 2 of them. 2 of them. For me, I'm on the next one. Do you guys have, iron 2 acetate we just did, right? Do you have iron 3 acetate? Try that one on your own. I'll do that up here. Let's see if we get the same thing. What's I think you get that. I hope you get that. I think. Is that okay? Yeah? 1 iron, 3 Chkus. And again, by the way, how many atoms are in this molecule? In math, when you see brackets, that means start inside there first. I do the same thing. So, ready? How many C's right there? 1 plus how many? Is 4, 5, 6. There's 7 atoms inside the brackets times 3, 21, 22. That's a big molecule. It's 22 atoms. And now you're starting to get a feel for how you can tell, are molecules going to be small or are they going to be pretty big? Okay? Is that okay? Let's skip the next two. Let's do the last one. Manganese IV perchlorate. Yeah, let's do the last one. I said skip the next two. Let's do the last one. Manganese. Don't use magnesium. Use manganese, which I got to look up. Oh, no, it's got a charge of 4 because they told me. I don't need to look it up. I know it's Mn. I was going to look up the charge, and then I went, no, they said IV, 4 plus. Perchlorate. That one I can never remember. Perchlorate. There it is. ClO4 negative. ClO4 negative. How do you know it's not an I? I think the chlorate comes from chlorine, the Cl, right? Is that right? Mn and then ClO4 in brackets with a 4 outside. 4 perchlorates for 1 manganese if it has a charge of 4 plus. Is that okay? So, after that now, in theory, I had initially said, do check your own understanding. I'm going to nuke that. Quiz is going to be, I'm going to give it to you right now. I have to show you a video of dogs teaching chemistry. Of course I do. But in theory, on the section 3.2 homework, which I gave out last class, Lena and Farine, I'll get you a copy during the video in a second. But you should now be, I might have given it out earlier, did I? Okay. You should now be able to do this one and the back page. That's going to be handed in if you want to next class. But if you haven't done already, you can, but you would have had to just figure out this. Maybe you did already. That's okay. Yeah. The one that hang on, let me just pause the video for a sec. So your homework for next class, and unfortunately you're not going to get any time in class to work on it, is finish off this section 3.2 homework, which most of you got mostly done already, but then also this take-home quiz number 1. So what I've done is I've given you either a formula or a name. Some are multivalent as you get further down. Some are polyatomic. So for example, I can definitely tell you that this one right here is polyatomic because it has more than 2 capital letters. And then also see if you can count up the total number of atoms in the molecule like I've been doing with the examples here too. That's absolutely due next class. Unfortunately, I can't just press pause. I also gave you section 3.3 fill in the blank notes. Can you get this second handout out, please? We're going to start the lesson today. We're going to finish it off Thursday. Then we're done the whole unit, the whole chapter. In fact, then we're done, Nicole, all of chemistry. Okay? Pardon me? Why don't we do a lab? I don't have time to fit one in before Christmas. I'm going to try and do more labs when we get to electricity so you guys can shock yourselves. That's funner. I put 5 out there, I think. Oh. There you go. Wait, did you just time that out? Yep. Okay, can you find it? Looks like this. I gave you 2 sheets. Did I miss your row? Okay, thought I had extras. So, the last topic is looking at what are called physical and chemical changes. So, kinetic molecular theory, or our abbreviation that you can put in the blank is KMT, kinetic molecular theory. All particles are moving. They're closer together in a solid, they're further apart in a liquid, they're furthest apart in a gas. Okay? So the black stuff is what I think Phil goes in the blank that I underlined. And then chemical bonds is how atoms are held together. That's a short definition, but chemical bonds are what holds atoms together. Last year I taught this, I showed both of these videos at the end. I'm going to show them at the beginning and see if then when we go through the notes you say, oh yeah, I've seen that already. So put your pencils down once you've filled in the blanks. Continue. So, physical versus chemical changes. What's the difference? In a physical change, here is the key idea. Chemical bonds are not broken. I'll change colors to make it stand out a bit more. So particles are still the same. But the size or shape of the object has changed. Or the physical state. So going from solid, liquid, gas, that's a physical change. Here's a classic physical change. Ripping a piece of paper. I haven't created anything new. Here's another physical change. Crumpling a piece of paper. I've made it look different. I've made it look different. Okay? Got that okay? If not, I'll come back. They do often involve an energy change because in kinetic molecular theory, when you added or took away heat, that's how you made it solid, liquid, or gas, and that changes the amount of energy each of the molecules possesses, how fast they're moving. Words to describe physical changes. Tear. Cut. I think I gave you cut. Boil. Dissolve. Anybody else, can you think of any other words that you think might describe a physical change? I got to be careful. Burn is a chemical change because when you burn something with a flame, actually the carbon combines with oxygen in the air to form carbon dioxide. You actually have new stuff being produced. So baking, cooking, those are actually all chemical changes, which is why, by the way, raw fruit or raw food can poison you. Cooked food, fine. Tastes great. Yeah. Freezing. What else? Here's what I came up with. You can add these. Ripping. Cutting, I think I gave you already. Grinding something up, that's a physical change. Shredding would be a physical change. Tearing. Oh, and then you know what? All of the words, remember this chart from, holy smokes, 2 whole chapters ago? Sublimation, deposition, evaporation, condensation, melting, solidification. Those are all physical changes. Those are all physical changes. Really what you want to ask yourself is, did I produce something brand new? If I didn't, that's a physical change. Physical changes are, did I include that in the notes? Let me think. No. You can write here next to where it says other words. Physical changes are usually reversible. Not always. When I rip a piece of paper, Nicole, I can't unrip a piece of paper very easily. But when I freeze something, can I reverse the freezing? Sure. If you can reverse it, almost certainly it's a physical change, not a chemical change. Mr. Dueck, I think, has kind of a neat example. Here's a physical change. So you ready? So there was a great example of a physical change. In a chemical change, bonds are, here's your words to underline, broken and reformed. You with us, Dan? Yes. Okay, you zoned out there. With new atoms. Key idea for a chemical change, something new is produced and it's non-reversible. Now, just because it's non-reversible doesn't mean it's automatically a chemical change. Again, this is not reversible, but that's a physical change. I haven't produced anything new. It's still paper. If it is reversible, you know it's a physical change. If it's non-reversible, it's probably a chemical change, but what you really ask is, was something brand new produced? On your test, I'm going to give you some examples of situations, and I'm going to say physical change or chemical change. What do you ask? Was something, Aiden, new produced? That's a good optical illusion, but I want your attention span here. Okay? Words to describe a chemical change. Burn. Anytime you're burning. Rust. Other words that are chemical changes? Well, here's what I came up with. React, like a chemical reaction. Oxidize, that's the fancy chemical word for burn, because really when you're burning something, you're combining it with oxygen, which is why you need oxygen for flame. Precipitate. Combine. But I'll give you some more common words. You ready? Bake. Broil, not boil, broil. Grill. Cook. In all of those, you're adding heat, but you're actually getting a new chemical reaction. Now, cook, as long as you're not just boiling water and calling that cooking. I mean, you're combining some ingredients and, oh, I get something new. Baking a cake is classic. You start off with a bunch of ingredients and you get something totally new coming out of the oven with a different texture, and it's not reversible. So we're going to do one more key idea and pause. If you are trying to decide if a change is physical or chemical, here is the key question. Was something new produced? That's the key question. If the answer is yes, which one is that, physical or chemical? Chemical. Okay, so yes, chemical change, no, physical change. The whole question of, is it reversible? Okay, if it is reversible, it's not chemical, but some physical changes aren't reversible either, so I can't just use that. So we did the front page. Thursday, we'll mark take-home quiz number 1. We'll finish off the back page. I'll be giving you some homework for this and take-home quiz number 2. Friday, take-home quiz number 3. You'll mark it on Tuesday via video. My substitute teacher will play it for you. And then a week from Thursday is your test. I don't know what